Hi all, in this video I am going to show you how to adapt a conventional FTIR equipment to perform FTIR measurements in situ in electrochemistry. To do it, of course, you need a spectrometer. In this case, I will use as an example the IR Prestige 21 from Shimatsu. If you open the sample container, you will see the IR beam crossing it from the source to the detector. To perform an spectroelectrochemical measurement, you have to use an accessory. For example, the VMAX2 that we are showing here. Attaching this accessory to the equipment, you will be able to guide the IR beam to the spectroelectrochemical cell, as you will see soon. We have made a figure here for you to have a better idea of the IR beam path inside the accessory. At the top of the accessory, we have inserted a homemade lid to adapt one or more of our spectroelectrochemical cells. Okay, now we need a cell. In our manuscript, Versatile Spectroelectrochemical Cell for In Situ Experiment, Development, Applications, and Electrochemical Behavior, we describe in detail the components of the cell and how to set it to perform FTIR in situ experiment in the reflectance mode. In this figure, we can see the components of the cell. Starting from the left and going clockwise, we have the reference electrode, the working electrode, the two compartments of the cell body, one containing the counter electrode, the O-ring, the two bigger to adapt the windows and the smaller to avoid leaking between the two compartments of the cell body, then one of the many windows that we can adapt to this cell, and finally the lid to attach the window to the cell. We have recorded a video for you to understand how to set the cell. First, we are putting together the compartment of the cell body. Look that we fix them using screws. Then we insert the bigger O-rings in the front of the cell. We have two O-rings, simply to permit to adapt windows with different sizes. Look that the window is placed on the O-rings and then pressured and attached with the lid. Once that the cell is closed, we insert the reference electrode by the side, look here, and finally the working electrode by the back. Look that the face of the electrode ends in front of the window. In this figure, you can see the components of two different holders. One was designed to work with windows and the other to use prisms. These holders are meant to mount some of our homemade glass cells that we use in different kinds of experiments. That is to say, in spectroelectrochemical experiments, in photospectroelectrochemical, and using different configurations. The video shows how to set the holders for the window, which is rather similar to that for the prism. In the case of the prism, we also use a Teflon homemade holder. In this case, we are using the calcium fluoride prism, but you can install the zinc selenide or the silicone one, for example, in the same way. As you can see, we use screws to press the prism against the holder. The calcium fluoride prism is the most used for conventional reflectance experiments. You can use, for example, the zinc selenide prism and deposit onto it a thin layer of gold and perform an experiment in the FTIR mode. FTIR stands for Attenuated Total Reflectance. You can do Seigas, and there are many options that I will not discuss here. Now that the holders are ready, they can then be attached to a conventional 3 electrodes electrochemical cell. First, we insert the counter electrode. Then we take one of the holders and screw it with the cell. This way, the cell is closed at the bottom with the window or the prism. Then we add the other components of the cell. With all this, we are ready to perform in situ measurements in electrochemistry.